One thing involving radical functions and equations and expressions that people a lot of the time get confused about is extraneous roots. So anytime we solve a radical equation, lots of the time we see that there's either like one or two solutions that we get that isn't even true. So for example, you might get a solution where x equals, I don't know, 1 and negative 3, say. And let's say the 1 didn't work. Why didn't that one work? Why did we only have a one valid answer out of two, even though when we solved it algebraically, we got two solutions? Well, I'll explain that right now. So in my last couple of videos, I used the example or in my last video when we just kind of talked about radical equations, right? That's kind of introducing an equal sign when we're talking about rational expressions, right? We got, actually, I wrote negative x here, so I'll do the exact same one. So negative x minus the square root of x plus 7, we said that was equal to negative 5. Okay? And what we did was we solved this algebraically. So we moved the x over, because remember, we always want to get the radical on its own when there's only one. So we got negative square root of x plus 7 was equal to negative 5, and then we added the x. So negative 5 plus x. So the deciding factor in this solution, where the extraneous root really comes up, is right here. So notice how when we solved for x in the last question, the next thing we did was we divided by negative 1. Okay, so we divided by negative 1, and then that changed the sign of everything on the right, right? Because this became positive 5 minus x. Well, what happens after that? What did we do? Well, we got the positive square root of x plus 7 was equal to positive 5 minus x, right? And then we squared both sides. So we squared both sides, and we got the inside x plus 7, and we got that equal to be 25, right? Because 5 squared is 25. And then we got minus 10x, just combining like terms, and then plus x squared. Okay, so why does this step in the equation make it extraneous? Why did we get an extraneous root? Well, it's because since we're squaring both sides, it actually doesn't matter if this is positive or negative. Okay, it actually doesn't matter. So if we were to not make a negative, right, if we didn't divide by negative 1, let's just say we kept it the way it was, didn't divide it by negative 1, we got a square on both sides. Actually, I'll square the whole thing. So if we take this negative 1 and we square it, we're going to get positive 1, right? Because negative 1 times negative 1 is positive 1. And then we square this radical, and like before, we just get x plus 7. And in the last kind of step, when we divided by negative 1, we were squaring positive x, or positive 5 minus x. In this case, it's negative 5 plus x. So before, right, we got 25 minus 10x plus x squared. If we take negative 5 and we negative 5 plus x and we square it, we're just multiplying it by itself, right? Before it was positive 5 times positive 5, now it's negative 5 times negative 5. This is still positive 25. Before it was positive 5 times negative x, this time it's negative 5 times positive x. Notice how it's still minus 5x. Do the same thing with x and negative 5x. Positive x times positive x is positive x squared. Combining the negative 5s, we still get negative 10. So anytime we square both sides, we're including an extra solution. So I said that it doesn't matter if we divide by negative 1 on both sides or not. Okay, but it actually does. There's only one instance out of the two possibilities. We can divide by negative 1, or we can keep it the way it is, but only one of them is going to work. Okay? So when we square both sides, we're saying the negative essentially doesn't matter, and it actually does. Okay, it actually does. And that's kind of my short explanation on why extraneous roots come up, is because it also happens when we square root a number, right? So when we square root a number, when we're doing other types of equations, extraneous roots also come up when we're doing, for example, quadratic equations, right? They also come up. So anytime we square root or or square both sides, we're going to get an extra solution most of the time. Okay, and we can figure out what that extra solution is by just plugging it back into the original equation and seeing if the left side equals the right side. Okay, so that's why extraneous roots come up. Hope this was helpful, and I'll see you in my next video.